All right, so we are the 25th today, so we're close to a month into the course. I'd like to take a little bit of time to get some feedback from you guys today about the course so far. See if there's anything that we can adjust or improve upon. So the first thing I'd like to ask you is, how do you find the assignments so far? Okay. The level of difficulty, easy, hard? Okay. So what I'm going for is something like 80 to 90% being, let's say, fairly easy for people with programming experience, and the last 10 to 20% being a little bit more of a challenge. Because there's a wide gap in experience coming into this course. The idea is to narrow this gap by the time we reach the end of the course. How about the lectures? So there's sort of different styles of lecture. One is what I do here, which is programming in front of you guys. Another style is to come in with a deck of PowerPoint slides or PDF slides with code samples on them. It's sort of up to the lecturer how they prefer to do that. I find this maybe is a little more helpful because you see that everybody makes tons of mistakes while we're programming, and I think it's probably more useful for you to see mistakes being made and corrected than it is to see perfectly finished programs right from the beginning. But I'd be interested in any feedback you have on that. Okay. I mean, I don't know. Yeah, I'm not sure how I would teach this course with a bunch of slides. When I've tried things like that in the past, I find I move a little too quickly. And you may say, wow, you could move quicker than you do now. Yes, if the code is already written down for me, then I actually probably teach a lot more quickly. Do you guys feel like you're understanding the material? And are the tutorials and or assignments helping with that? Yeah. Yeah, I agree. I do sometimes run off without taking time to explain it. Often that's because I'm running out of time and I would like to finish the thing by the end of the class, but I agree. And if that happens, please do try and stop me. It's actually not the end of the world if we don't finish the program by the end of the class. So I would prefer if you did stop me if you see that happening. I guess the next question is about motivation. Do you understand why we're learning this stuff? So do you feel that this is useful stuff to be learning as a computer scientist? Is there a good reason to be learning this, or am I just torturing you? That's what I would like to know from you guys. Do you feel like you're just being tortured, or is this useful stuff to learn? Okay, good. So you see where this is going. Yeah. Why are we doing it in Python? The options are Python processing or Java, straight up Java. Python I like because for those who haven't programmed before, there's very little syntax to get in the way of just starting to do stuff. Your first Java program, for instance, starts with the word class and then the words public static void main string square braces args curly braces, and then you can actually start to program. In Python you can write a program which is just the words print hello world. In Java there's sort of a big startup cost. So that's why I like Python. Some people prefer a more structured language like Java, but I find that it makes it harder to get anything done. So for instance, if you think about the game that you're currently developing for your assignment, if you've started, if you've programmed in Java before, think about how much more work that would be to write in Java than in Python. All right, so mostly it seems well motivated. And the programming language, I mean, Python, I told you the pedagogical reasons that I like it, but from a practical reason, it is just simply a popular programming language. There are many, many big projects that have been done in Python, and so you know, by the time you finish this course, you actually have a useful skill, something that's usable in many industries. I guess the last thing I'd like to ask is any requests for something you would like to see? Yeah. So where you can find the answers to the advanced questions, somebody has to do them. If somebody has done them, you can post your answers on the forums. That's a recommended way of doing it. Some of them I have done. They're lying around in different parts of my hard drive. But there's no problem, let's say, on, when's the last tutorial? Is there a tutorial on Friday? I don't think so, right? Tuesday, Wednesday, and Thursday, maybe, our tutorials. So I have no problems if somebody wants to, on Friday, post their solutions to, or their attempted solutions to the tutorial questions that week from the preceding week. So post them for discussion or ask how somebody solved it, or we can figure out if anybody ever solved it. Yeah. Will we cover networking? I wasn't planning to. If you are interested in one aspect of networking, which is making a web server, the book does cover that. So the book actually uses this web development framework. I forget what it's called. No, it's not Django. I forget what it's called. But anyway, one of the way the book progresses basically goes from making text games like we're doing in this class to making a web-based game through a web server, and so that aspect you can get from the book. I wasn't planning on doing too much networking. One reason is that it's a little bit dangerous. You can get into a lot of security issues once you do networking. If I teach you how to do things like, well, set up program your own web server, that is dangerous for your own machine. If I teach you things like how to retrieve things from the web, that's dangerous for things like your Google account. So the first, sorts of projects people try and do are scrape stuff off of sites like Kijiji or Google, and then they realize that they're violating the terms of service, and they get suspended from those services. So it's slightly risky to do network programming at this stage. Yeah. Well, no. I mean, yes and no. I mean, here's the problem, which is I can easily. So the question is, how can I use a timer in a game rather than just a sleep function? So you say timed raw input in Python, you Google that, you get a nice answer on Stack Overflow, and you see, actually, look, there's a really easy solution right there. So here's a recipe, and we can even try it out. So this is supposed to wait 10 seconds for me to enter something. I don't like the spacing there. Let me fix that. Okay. So there's one issue already. I don't see a prompt, but I know how to fix that. Okay, so now it's asking me to enter something, and I have 8, 7, 6, 5, 4, 3, 2, 1. So no input in 10 seconds, this thing goes away. That's what you guys want, right? Many of you are looking for exactly that for your games. And I wish I could give it to you. This is a solution that works for me because I happen to be running Linux, and Linux uses this sockets mechanism in a fairly standard POSIX compliant way. It works great. Try this solution under Windows, it won't work for you. Try it under Mac OS, it also won't work for you. So the problem is each of these operating systems has their own way of doing this, and there's no nice cross-platform way. Yeah?
Python doesn't have like Java has this JRE,
Yes?
which everything makes it cross-platform. Python doesn't do that.
Well, Python has things like Pygame and tkinter, which are graphical user interfaces, the same way that Java has things like Swing and whatever else there is for graphical user interfaces. But Java also has no nice way of doing console, fancy console stuff. It just has normal printing to console, reading from console. There's no timers, no stopping things that's portable in Java either. Yeah? That's a good idea. Let me put that on my to-do list, regular expressions. I assume you wanted to do regular expressions. You're not asking because you're going to drop the class if I say yes. So let's put that on there. So blame him when it comes time to do this. Okay, so the answer for timed input like this is there's just no clean way to do it. And I don't want you trying to mess around too much with it, because then you'll be submitting games that the TA happens to run on a different kind of system than you have, and it doesn't work. You lose marks. The TA gets frustrated because they can't play it. You get frustrated because you lose marks. Just do the crappy version of timed input that doesn't kick the user out of the prompt. It just tells them if they took too long. Yeah.
Could you show us how to make a CSV file or make any text file that can be read in Python?
Sure. So here's, for example, a CSV file. First name. This is, so I've just created a file called names.csv. CSV stands for comma-separated values, and so I think it's sort of obvious what the format is here. Each line, think of it as a row, and the different fields on each line are separated by a comma. And now how do you read this in Python? You open the file, it's called names.csv, and you read it. So let's take a look at what that gives you. So that gives me basically the whole file as one big string. So you see it there. There's the first line, there's the new line character, second line, the new line character, and the last line, the new line character. So if I split this text into lines, I actually get an array now, where each line is an element of the array. The new line characters go away. They get chewed up by this split. Yeah?
What are advantages in using a CSV file instead of a TXT file?
Well, there's CSV files are just a text file, a TXT file that's formatted a specific way with these commas. But there's no, I mean, you can use whatever file format is easy to parse, right? The first thing you do is to open the file and read it. After that, you have the whole file as one giant string. So whatever you can do with strings, you can do with that file. So whatever's most convenient for you. Yeah.
Is there a cross-platform way to clear the terminal screen?
Sorry. Yeah, so no nice cross-platform way to clear the terminal screen. Again, you could write one that, on one thing issues a system command called clear. On another operating system uses the con.io library. And sorry, I know it's frustrating when you're trying to actually make a game that doesn't look total crap, but don't worry. You're going to have a chance to make a really good game. Yeah. Sorry, what's that? Yeah. Yes, you can figure out the platform from sys. You can find out which major operating system it is, and maybe even some minor version information, and then output a code that may or may not clear the terminal for that thing. Yeah. It has to be either in the directory you're working in, or you have to say which directory it's in. So, for example, this file is actually in so what was if it's somewhere else, you could do so that should also work as well. But I recommend not doing that kind of thing, so this is the full path to this file from the top level directory right up to this file. But if you do something like this, when a TA comes and unzips your assignment or takes your assignment, it's probably not going to be in exactly that directory on their computer. So best thing is just keep it in the same directory and don't specify any path to it, just specify the file name when you open it. Yep.
Can you do a relative path? Say if you wanted to go up, or you basically do dot dot thing?
Yeah, you can do things like go up one path, go up one level in the directory structure, dot dot, and then then specify things. So you can do relative paths from the current directory. In fact, just the name of the file is a form of relative path. It's just in the current directory. Yeah.
I saw on Staple it said for clearing the screen, you could just put a bunch of new lines. Just basically clear the.
Yeah, that's one cheap way to clear the screen is to print, 50 new line characters. That'll do it. Depending on the speed of your terminal and displays, people might see it zoom up, but sure, that works. Yep.
Could you split the file so it's like first name and then last name for each?
Yes. So we had split the lines, and so now this thing is split into lines. So now we have for each line we have a string, and now typically if this is a CSV file, you do one more level of splitting where you do something like B is equal to, you take each line and now you split it. And you split it on commas, not on new lines, because in this CSV file, commas are the thing that denote the fields. And you want to do that for every line in this case, it's in an array called A. And now if you look at B, it has one element for each line, and that element is itself an array with this thing split up into these three strings. Yeah.
So if I wanted to do it like the one we did in class, there was a question and 4 options.
Yep.
How could I split that? Would I use the same method?
Yeah. That's the easiest way to do it would be the question is on the line, and then the 4 options are listed after it with some special separator between each of them.
So in the actual code, how can I specify that this is the question, that these are the answers?
Well, so the trick is a CSV file you should pick. So it's called CSV because it's comma separated values or whatever. But you should pick a separator which doesn't occur anywhere else in any of the stuff. So comma is not a great one often because maybe a question would have a comma in it. But things like a vertical bar, that's a nice one. Probably not going to show up in any of your questions or any of your answers. So just one line, question, vertical bar, option number 1, vertical bar, option number 2, vertical bar, and so on. And then when you do the split, the only difference is instead of splitting on commas, you split on the vertical bar. Whatever your favorite character is that's not likely to be anywhere else in the file. Yeah.
How do you make it so that only the first name is printed? Like just the first name itself?
So you want to see, well, so if we look at this whole array B, it has 3 values, and each value is itself an array, and it's of length 3 because we put 3 things on each line. So if I want to know the first name of the 1th element in B, that just looks like this. B at 1, that's the line that says Pat Morin 41, and at position 0 in that array is Pat. So this is what's sometimes called a multi-dimensional array or a 2-dimensional array. It's really just an array of arrays. Yeah? What if I didn't declare B as an array? So what do you mean declare? Then it won't work. Because this weird syntax of this expression line.split for line in A, this is the list comprehension syntax. And it's always surrounded by these square braces. Yeah. Yeah, you could do that. But it starts to get tricky because, well, let's see if we can manage to do that. So B is now a 2-dimensional array, and we said one thing you can do with a string okay, good. So let's say C is equal to list S for S in B, S in T, for T in B. There you go. That's a 3-dimensional array now. Don't worry if you didn't follow that. But that basically took, so this is a 2-layered list comprehension. The first variable, this outer variable T, iterates over each element of B. And then, which is these little arrays of length 3 that have Pat Morin 41 in them, for instance. And then this inner variable S iterates over Pat, and then it takes on the value Morin and it takes on the value 41. And here, when you convert a string to a list, that makes it into an array of individual characters. So this really is a three-dimensional array now. We could look at C at 1, at 2, at 3, or maybe C at 1, at 2, at 0. And we see that it's a 4. That's the 4 from 41 here. Not so easy to follow, but yeah. So a list, for me, list and array means the same thing. I sort of warned you guys about this, but list and array is the same thing in these discussions. Yeah. If you borrow a snippet of code from the internet, I would like you to acknowledge it in your source code. So something simple like, well, we just stole something off the internet, so you could say something like, I didn't know how to do timed input, so I took the following code from here. Okay. So doing that will guarantee that you will not get charged with something like an academic offense for plagiarism. But what I don't want you to do is to do something like go and find a game written in Python on the internet and submit that as your assignment. Now, you can, if you do that, the two things can happen. If you do that and you don't acknowledge it anywhere, then you're actually in fairly big trouble. So if that gets detected, that'll be reported to the dean of students as a academic transgression. It's actually plagiarism. You'll have to go talk to him and explain it. It'll go on your permanent record, and you'll probably get 0 on the assignment. If you do that and you acknowledge where you stole it from, then the only thing that will happen is you'll probably get a 0 on the assignment because you didn't actually do any of the assignment yourself. So it's fine to borrow code from places that you know, bits of code that you want to use if you acknowledge it. But you know, the more you borrow, it means the less that you actually did, and so there's a trade-off there. Yeah. Would a what? Sorry, I missed the. What do you think is going to happen? Oh, will your marks suffer? No, not if it's something fair. I mean, if there's some. If there's just some component of a game that you didn't understand. So, for instance, maybe your game is like a typing game or something, and your game gives part marks if somebody mistypes a word, but it's close to the actual word that they're supposed to type. So actually checking if one word is close to another, that's sort of a tricky problem, and what does it mean to be close and so on. But you might have done some research and found on the internet, oh, there's this thing called edit distance, and I found some code that computes the edit distance for 2 strings, and I thought this would make my game better. So now I am as part of my game, I check the edit distance between the input and what they should have input, and their score is based on that. But I have no idea how to compute edit distance because it's complicated, so I borrowed this code. That would be perfectly fine. On the other hand, if you say, well, I found this Hangman game on the internet, and here it is, then your marks will suffer because you didn't add anything to it. Yeah.
So say we did what you did right there, we get marks off?
No, that would be fine. Here you would get marks off because the TA might run it on a Mac OS machine and it won't work for them, and then they'll be upset. But not for borrowing code this way. Yeah. Yeah, so it's quite hard in a week to come up with a truly original game, and so yeah, borrowing stuff from class is fine, and implementing a game which certainly somebody else has done before, that's fine too, as long as the implementation you did yourself except for the parts which you've pointed out. Okay. Good. Lots of good questions and answers today. All right. So today I want to talk about an issue which is always a problem for new programmers, and that's called the issue of equality versus identity. So we've seen sort of two equals operators in Python, where we say things like x equals 5, y equals 6. And now if I say x equals y, what does that do? So that sets x equal to 6, right? So that assigns the value of y, the thing on the right-hand side, to the variable x. Some older programming languages, this is such a serious operation that they made it obvious. So one problem with this sign equals is that it has such nice symmetry that if you're not used to it, it's not clear what's being set to what. Is x becoming y or is y becoming x? Some older programming languages would do things like this, but that's greater than, less than or equal to, so they would do things like this. So it's sort of like an arrow pointing from y towards x, and that's the way you need to remember this thing. So that's this single equal sign is the assignment operator. It sets the value of the left-hand side equal to the value of the right-hand side. Now what about this? So that will compare the values on the left-hand side and the right-hand side and tell you whether or not they're equal. In this case, the answer is false, because x is 5 and y is 6. But if I set x equal to 6 and ask again, then the answer is true, because both x and y are equal to 6. No big surprises there, right? So, and if I define some array, a equals 1, 2, 3, b equals 4, 5, 6, is a equal to b? False. A is an array that contains 1, 2, 3. B is an array that contains 4, 5, 6. All right, so let's set B. Try changing this. 1, 2, 3, A and B. Now is A equal to B? True. Okay, good. All right. Now pay attention. Let's set C equal to A. So here's A, here's C. Is A equal to C? True. Okay. Let's change A. Now is A equal to C? True. Wow, that's weird. C is 1, 2, 3, and A should be 1, 99, 3. Let's look at A and C. Aha. So, something funny happened here. Something unexpected. All right. Now, where did B end up in all of this? B was also an array that contained 1, 2, 3. Are A and B still equal? No, they're not. A has 1, 99, and 3, and B has 1, 2, and 3. So somehow there's something really different about the way we made B and the way we made C. Something really fundamental happened here, because when we changed A, C changed and B didn't, even though they were all 1, 2, 3 at some point. All right, so what we need to understand here are these so-called box diagrams. And so when we do something like we say A equals 1, 2, 3, well, we create this variable called A. And the way to think of a variable is it's just a little box. You can't put a lot of stuff in this box. In fact, really the only thing you can put in this box is a reference to some value. So this box tells us where to find some value. What is the value? Well, the value is this array that contains 1, 2, and 3. So this is the picture to keep in your mind. You have a variable called A, and A says, all right, when I do this assignment, A, so this is this assignment here, where I say A equals 1, 2, 3. So the way you think of this as whatever's on the right hand of the assignment gets evaluated first. That's the creation of this array here, 1, 2, 3. And then this variable on the left-hand side, which is this box, gets assigned a reference to this thing. So it says, this is the thing, this is your value now. All right? So, the next thing we did was we said B equals 1, 2, 3. So what happens there? What's that? Exactly the same thing that happened at A. So the right-hand side gets done first. An array gets created that contains 1, 2, and 3. And then the left-hand side defines this variable called B, which we just think of as a box. And B references this array, 1, 2, 3. I'm still getting used to not writing directly on the screen. Okay. So that's what happens there. And now we said C is equal to A. So what does that do? Yeah? Yeah. So we get this C on the left-hand side, and the right-hand side was A. Well, A is a reference to this array over here, and so C becomes the same reference to the same array. So this is the picture we have of this thing. There's actually two arrays that contain the values 1, 2, and 3. And there's three variables that refer to these arrays. A and C now refer to the same array. So we can test our understanding of this. So I'll say something like A at 2 is equal to 66. So what does that do to this box picture? Yeah. Yeah. So it changes the value in A at 2. What's A at 2? Well, this is 0, this is 1, this is 2. So this value over here gets overwritten with 66. Which means, since A and C refer to the same array, A looks like that, and so does C, because it's the same array. B, on the other hand, is completely unchanged by this. Yeah?
Is it possible to separate A and C now? Like if
So to separate them, we need to make one of them refer to something else. So for example, we can do something like, say, C is equal to 4, 5, 6. So that will do the following. Where do we go? We end up with a new array 4, 5, and 6 in there. This part of C gets scratched out, and C gets redefined, reassigned to point to this new array. So now there's 3 arrays and 3 variables. A refers to one of the arrays, B refers to one of the arrays, and C refers to one of the arrays. All different. Yeah?
You've done C exclamation mark equals A, so C does not equal A.
So let's not do the 4, 5, 6. Let's leave it the way it was, A and C. And you want to know if you ask something like this. So this is a question, right? It's not an assignment or anything. It's asking, is it true that C is not equal to A? And it's false because it's really the opposite of this one. If C equals A, this is false. Yeah. If you set C equal to C like that, no. If I set C equal to C, well, let's fix this picture because we never actually moved into this other world. So we are still living in this world where C and A refer to the same thing. So if I set C equal to C, well, it says, let's take the thing that C refers to, that's on the right-hand side, it's this array, and let's have C refer to that. So we overwrite C with the same pointer again. So it doesn't do anything. If you want if what you really are asking for is a copy of A, there's several different ways to do it. Or C to be a fresh copy. You can say things like C is equal to list C. This will give C a new, basically, list will make a copy of the existing list, and now C will refer to it. So if I do that, then that really creates a new list with 1, 2, and 66. C now refers to this new list. It no longer refers to this old list. So we have A, we have C, A equals C, but now if I change A, that doesn't change C. Okay? This is really important. This is an incredibly important distinction, cause of many, many programming errors. Yep.
If we do that C
If we say C, all right, so let's go back to C equals A. So now A and C refer to the same thing. Keep our picture up to date. And you're asking if we do what with C? Yeah. So now A and C are the same, really referring to the same array. So if I change a value in C, C at 0 equals 22, then indeed the value at A changes also. That change is really just going and setting this value here to 22. Since both of these refer to the same array, now they both see 22 there. Yep.
Is there any point to setting C equal to
Is there any point in setting C equal to A? Well, for one thing, it happens all the time. For instance, we've actually used this before. One of the functions we defined a while ago, I think we did this anyway, or maybe it was an assignment. So we defined a function called 0 of A, which was going to set all the values in A to 0, right? So we said for I in the range of the length of A at I equals 0. And this is so now we could say something like, just to keep things fresh, E equals 1, 2, 3. This is E. Now if we call 0 of E, then really what's happening is 0 is this function. It takes an argument A, which is being set now to the same array that E points to. Okay? And so that's really critical, because when I call 0 of E, that really sets E, this array, to 0. Even though internally this thing thought this array was called A and it set all the elements of A to 0, A and E refer to the same array. So this happens all the time. In fact, this is such a source of errors, of problems. It's called aliasing, because this one array has more than one name, more than one alias, that there are languages out there which are specifically designed to avoid having more than one alias for anything. Really hard to use languages, because we're so used to aliasing, doing what we want. There's this new programming language called Rust being developed by the Mozilla Foundation, that the whole language is built around the idea that no variable should be referenced, no piece of data should be referenced by more than one variable. It's supposed to save a lot of programming errors. I found that it just makes it extremely difficult to program. At least if for the kind of work that I do, it just makes it really hard to program. So it shifts the finding of bugs to the time that you write the program rather than the time you run the program. But that's neither here nor there. So it sort of happens all the time. If you want to avoid it, if you don't want two things to refer to the same array, there's a couple of different recipes for that. Let's say I want B to look just like A but not refer to the same thing. So we saw that you can set B equal to the list A, and then you actually have two different lists there, each containing 1, 2, 3. Another way to do it that I like is to say B is equal to a slice of A that starts at the beginning and finishes at the end. So where you don't specify anything, so it's just a total copy of A. Yeah.
If you change A, would you change
This way?
Yeah.
With the slice? No.
It would just stay
So a slice really gives you a fresh new list. So let's just check that. So you get no change to B there. The real danger is when you say just straight things, one variable equals another variable. That always means they now both refer to the same thing. Now, sometimes this doesn't matter. So sometimes it doesn't matter if two variables refer to the same thing. And that's true if the kind of thing they refer to is what's called immutable. So if I say x equals 5 and y equals x, well, x equals 5 and y equals 5. So they both, the picture really is it really is like this: x, y, there's some integer called 5 living off somewhere, and they both refer to it. But that's actually impossible to tell the difference between that and a picture like this. And that's because integers are what's called immutable. You can't change them. What am I going to do to this 5 here? Nothing. It's just fixed. It's just the integer 5. So arrays are dangerous because you can change them. And so when two things refer to the same array, you change one, you change the other. But the integer 5, you can't change. If you try and, there is no, it's not valid in Python to say, oh, now 5 equals 100. That's not an assignment. It's just not something you can do. Yeah?
What if you add like 1 to y? Does that do that stuff?
Nope. So if you add 1 to y, what you're really doing is saying y equals y plus 1. So that computes the right-hand side, which the right-hand side is 5 plus 1, so that creates this integer called 6, and then it assigns that to y. So now the picture looks like that. Doesn't affect x. Okay. So for some types, this issue of aliasing is not so important. For integers, it doesn't matter because integers, they're just these fixed values. For floating point numbers, the same thing. So for any number types, basically, it doesn't matter if they're what's called equal or identical, but where it starts to matter is when you have arrays / lists. And the reason it matters is because these things are mutable. They can be changed, which means if you change it for one reference, it gets changed for all of them. Now, sometimes you would really like to know so now A and C refer to the same list. B is a separate list all by itself. And sometimes you would like to be able to tell the difference between these two situations. Maybe you have two variables, A and B, and you want to know if I change one, is the other one also going to change? Well, one way you could try and do it is to change one and then see if the other one changed, but that's sort of letting the damage is done already in that case. But Python actually offers another comparison operator that allows you to do this. So we've seen A equals B and A equals C. Everybody equals everybody here in this case because they're all an array that's 1, 2, 3. And arrays are equal if they have the same length and the same values at every position. But we can ask, is A B? So there's this other comparison thing. So think of this as another kind of equality test where we ask, is A the same thing as B? A is B. Meaning, do they refer to the same array? So is A B in this example? False. A is not B. They don't refer to the same thing. There's two arrays. One that contains 1, 2, 3 that A refers to, and a different one that B refers to. Is A C? True. Okay. So A is C is indeed true because A and C really refer to the same array. If this tells you if I change A, then I will also be changing C and vice versa. Yep. Yeah. So A and C are the same array because the way C was defined was to be equal to A, which means we never created a new array. We just used the array that was already there for A, and we just referred to it with C. Yes. And in fact, that array is sitting in memory somewhere, and both A and C refer to the same location in memory. Okay, so this shows up first for us with arrays because they're mutable. And very soon we're going to start doing, in fact, maybe even this class, we're going to start doing object-oriented programming. And now this will show up all the time because objects, many kinds of objects are mutable. You can change them, which means it matters a lot if two things refer to the same object, because if you're changing one, you're also changing the other. All right. Any questions? So one thing you have to look out for is you should really only use this is. Well, there's a few places you can use it, but what you should not do, for example, is to say things like, well, let's try. So now we have two strings, S and T. Are they equal? Yes. They're equal because equality for strings is treated the same way as for arrays. If they're the same length and you scan over all their characters one at a time and they're always the same, then they're equal. Are they identical? Actually, we don't really know. We can't always be sure. This is not a safe thing to ask for strings. So in this case, it's not true, but it might have been true. Sometimes it is, sometimes it isn't. If I said T is a very long string, so now S, T, we ask, is S equal to T? Suddenly that's true. And that doesn't really make sense to me, or it looks to me like we created a string, a different string T here that's a very long string than we did up there when we created S. But in fact, there's some optimization that happens behind the scenes, and Python decided that they could both be the same string.
Test for equality.
Oh, sorry. Good point. Oh, still false. Okay, good. So it does what you think here, but it doesn't always do that. We could try some examples. Let's say x equals 4, y equals 4, x definitely equals y. Is x y?
Yes.
True. Let's try x equals, I don't know, that. Y equals that. So x definitely is equal to y. Is x y?
No.
False. Why is it true in one case and false in the other? It just happens to be that Python, for performance reasons, keeps a bunch of small integers already created and uses those if you need them. But once you get to big integers, it just makes fresh ones every time you need one. So don't use is on things like integers because the results are sort of unpredictable, right? These two pieces of code look identical, except I used a slightly different value, and I got different results. So if you really want to know are two integers equal, use this double equality test. And similarly with strings, you may run into some optimization issues that two strings being identical even though you didn't think they should be. And again, for strings and integers, it doesn't matter because you can't change strings. You can't modify the contents of a string, so you never have this issue if it makes no difference whether or not two variables refer to the same string or not because you can't change either of them. Okay. would anybody like to ask me any questions about equality? So these have names. If I say A equals B, that is a test for equality. And if I say A is B, that is what's called a test for identity. It asks, are A and B identical? So that's the words that you'll see, equality versus identity. Yeah?
So with string functions, can you just use like a double equal sign for a long string as well? Because in Java, you use like dot equals and then
Yeah, so in Java, confusing for you guys, is double equals is actually the test for identity. And dot equals is the test for equality. So here, double equals is actually the test for equality, and is the test for identity. So look out, Java programmers. Double equals has exactly the other meaning in Python than it does in Java. Basically, we'll see when we do objects that double equals just calls a method on an object that asks if that object that it returns true or false depending on how some method is defined. Okay. Yep. Sorry, I'm having trouble hearing you. Yeah, I didn't do anything special in this invocation. That was just a plain old command line, so nothing fancy. But again, this whole thing I did with the integers here, it's unreliable. Might do different things under different Python implementations, so just avoid doing that. Don't ask if one integer is another integer. Ask if they're equal, because that's probably what you mean anyway. Okay. So the next part of the class is, and this is a good time to do equality versus identity, because we're going to start doing what's called object-oriented programming. So far we have seen things like how to define functions. Inside of functions you make variables, the functions call each other, all of that runs and gives you a program. And that basically is the way that programming was done for the first, I don't know, 35, 45 years of computing. In the late 70s, this so-called object-oriented programming languages were invented, and then they sort of caught on in the mid to late 80s. Actually, Carleton's computer science department was a real leader in this field. So one of the first schools in North America, probably in the world, to do object-oriented programming at the undergraduate level, to introduce it at the undergraduate level, was the School of Computer Science here at Carleton. This was pushed by some professors here who really liked this idea. One of them still teaches here. His name is Wilf Lalone. He teaches a fourth-year computer graphics course, which is really an interesting game-making course. And they had written books about these things. And most of them went off and started companies based around the idea of object-oriented programming. They're all super rich. One of them is this guy, John Pugh. Anybody heard of him? So if I'm not mistaken, so he used to be a professor here. He owns the Ottawa Fury Football Club now. This is not, so football, soccer club. This is not the first team he's bought. He's also owned, or maybe still owns, a women's team in the US League. So he has a little bit of money now after making a killing off of object-oriented programming. Another one of these guys is Dave Thomas, who gives away tons of money all the time to new startup companies. So these guys made it rich off of this idea of object-oriented programming by being the first ones to understand it. And the way it works is just a realization that a lot of things we program, especially in things like games and business applications, they're best thought of in terms of so-called objects. So, for instance, we just created a game last class where we asked a bunch of questions. And it was sort of awkward the way we had to do it. I mean, I can open that thing up. And here's the quiz game we created last class. And we saw that we load up this list of questions into a two-dimensional array. And on the second dimension, so basically each line, we actually had to write down these reminder to ourselves that at position 0 is the actual question, at positions 1 through 4 are the 4 possible answers, at position 5 is the category, and at position 6, it's not actually some number, we know what it is now, it's the difficulty of the question. So we had to write that down, and whenever we were, doing stuff in here, like we have things like, look, let's print the category and the difficulty. That's Q at 5 and Q at 6. And when we printed the questions themselves, well, we made a range here that was that went from 1 through 4. So there was this whole sort of remembering which part of the array was which part of the question. And the point of object-oriented programming is, well, actually, you can do better than this. Why not just give these things names that make sense, not just indices in an array? Why shouldn't we create something called a question, and a question has several parts. It has the text of the question, and it maybe has answer 1, answer 2, answer 3, answer 4. It maybe has a difficulty, and it maybe has a category. So this is what object-oriented programming is all about. And we'll do probably next class, we'll build this game again, this time using objects, maybe making it a bit more reasonable. But for now, I just want to show you a couple of objects. So let's think about some application in which we have, I don't know, it's an application that keeps track of, let's say, should keep track of people. So there will be these things in this application called persons. So, a person is one individual. And then there's, special kind of persons. There's maybe, I don't know, employees. And maybe there's another kind of person where there's visitors. So if you work in a government office, right, there's somehow some distinction between employees and visitors. So these are special kind of persons. And they maybe have different things associated with them. Like a person might have a first name. And they might have a last name. And employees may have a employee number. And visitors, I don't know, what do visitors have? Yeah, badge number or something. So you give them a badge when they arrive, you record their badge number when you enter them in the system. So something like that. And yeah, that means we could define a person as an array that has 2 positions 0 and 1, where 0 stands for first name and 1 stands for last name. But it would be just handier if we could call these things by some meaningful names. So we define these things called classes. And so the syntax looks like this. We have a class of objects called a person. And a person is a kind of object. Everything is a kind of object. That's where the name object-oriented programming comes from. So you yourself are a kind of object. And, well, when we create a person, so when we initialize a person, we would like to specify maybe their first name and their last name. So inside of a person, it supports this special operation called initializing a person, which keeps their first name and their last name. And so when you initialize a person, you might save that. So let's say. So there we've just defined something, a class of objects called person. Let's try it out. Okay, so this thing should work now. So let's make a person. First name is Pat. Last name is Morin. So that says, okay, that made a person object. And it's a person object that's at somewhere. So let's assign that. Let's make that object and assign it to this thing. So now we have this object called Pat. So off in memory somewhere is this object. There's a variable called Pat referring to it. And we can ask for Pat's first name. It's Pat. We can ask for Pat's last name. It's Morin. Okay. So the syntax here looks a little bit funny. Every time you want to create a new class, you usually want to create a special function to initialize it. And it always has this weird name. Underscore, underscore, init, underscore, underscore. And actually we'll find that every object, everything that you define inside a class, every function that you define inside a class takes an argument called self, which is actually this instance of the object. And now self, you can assign values to self, like a first name and a last name. In this case, when we create a person, we take 2 arguments. If we try and create a person without specifying any arguments, we get an error that says you're supposed to specify 3 arguments, but only 1 is given here. Okay, so we got the basic syntax for creating objects now, and next class we'll really start to use these things. Yep. Self refers to this object that we're currently working on. It's not what? I have no, I only have super rough notes like this.
I mean like the program.
The programs are all online. If you go on the course webpage, you'll find them all there. Yeah. So if you go on, let me just stop this thing.